Okay, well, let's, after these misadventures and adventures, let's go and look at some of the probability puzzles which involve conditional probability. Hopefully they'll, so first of all, we have the purple probability puzzle. Well, what that is, we have these two jars, left and right, and we have 50 red and 50 purple to distribute between them. And let's say, let's make a distribution, and we want to know what's the probability that you get a purple. With the experiment is you choose left or right, equally likely, just randomly, and then you reach in and choose a marble, one of the marbles given the distribution. Well, let's say that you divide them. Let's say that you put in the left, you put 50 red, but here you put 25 purple, and here over here you're going to have 25 purple, right? So I've divided the purple between the two, and then put the 50 red here, 0 red here. Okay, well, let's see if our events are our sample space. We can divide into left and right, where I chose a marble from the left. This is the event where I chose a marble from the left side. This is the event where I chose a marble from the right side. Okay, so this is going to be the probability that it's purple given the left times the probability of the left. Will, you have a question?
No, I did. I'm sorry, I misclicked.
Okay. The probability of purple given that it's right, given that you chose one from the right side, probability of choosing one from the right. Well, this is going to equal, well, the probability you choose a purple given that you've chosen a left one is going to be 25 over 75, right? Because you know that it's this is this is going to be the number that's purple and on the left, which is one of these 25 divided by the number on the left, which is 75. That's the definition of conditional probability, times the probability that you chose on the left, which is 1/2, plus the probability that you got a purple one on the right, which is 25 over 25, because you're absolutely certain of getting one on the right. And that equals, well, 25 over 75 is 1/3 times 1/2 plus 1/2, which equals 1/6. 1 over 2 times 3 plus 3/6, that's 1/2, which equals 4/6, which equals 2/3. So the probability here is 2/3. So the probability for this distribution is 2/3, and this enables you to sort of calculate that in a simple way. Now, let's say that we could choose, see if we could now if you could see that if I put like well, let's try where I put like 50 red on one side, 50 purple on the other. So here's distribution 2, where I put 50 red here, 50 purple here, and I see, well, what's the probability that you get a purple? Well, that's going to be the probability of purple given that it's left. It's the same formula, because we're still using we're just changing the individual probabilities. We're not changing the partition that we're using. Okay, so this is going to equal, the probability I get a purple if I have one on the left is 0 over 50 times 1/2 plus 1, because I'm going to get 50 over 50. I'm always going to get a purple one from here. times 1/2 equals 1/2. So this distribution gave me a probability of purple of 1/2. This one gave me 2/3, and 2/3 is larger than a 1/2. Now, likely, if you've thought about this, you can so at this point, does anyone have a distribution that you'd like me to try and calculate the probability for? The idea is to find the distribution that makes the purple probability as large as possible. You don't have to choose the best one. I'm just saying, is there one that you have whoop. Wow, that was exciting. My chair collapsed. But fortunately, I have another chair right here. Well, interesting events get recorded. Okay, so does anyone have a distribution of red and purple on the left and the right that they'd like to try? So you have 50, you can distribute 50 red and 50 purple any way you want between the two jars, and you want to maximize the chances of you getting purple. And this is one of the problems that I had asked you to work on. So if you haven't thought about it, then just figure out, just take a stab and see if I can then calculate the conditional probability for you, just the probability that it's purple, to check and see who can get the distribution that's maybe, can you get one like 1/2 is easy to get. Here's 2/3. Can you get one that's greater than 2/3? Let's see. I think I missed. Okay, someone has a chat. Okay, Will, yeah, I didn't have the chat up, so now I can see you have an idea. Okay, so you put 40 red here and 25 purple and 10 red here and 25 purple. Okay, so let's see the probability of purple is. Well, that's the probability that it's purple given that it's left, probability on the left, plus probability purple given that it's right, probability right, equals, well, the probability it's purple if you have the left is going to be 25 over 65, right? Because it's going to be the number, the conditional probability will be the number that's both purple and left, which is 25, over the total number that's left, which is 65, times 1/2 plus the probability it's purple on the right, which is 25 over 35 times 1/2. Okay, so let's then see what this is. Well, the fraction here might be it might be it might be difficult to do this. Let's see if we can't use WX maxima to calculate this. There's 25 divided by 65 times 1/2 plus 25 by 35 times 1/2, and that's 50 over 91. Let me bring this window and make it in the front all the time. Okay, so there's 5091. We want to know, well, what is this numerically? So we toggle the numerical output, do this again, and we see that this is a fraction of about 0.55. Well, this is not, so this is slightly above 50. So it's a little bit better than 1/2, but this 2.6 is going to be approximately equal to 0.67. So it doesn't get up to this stage. So this one is better than 1/2, but it is not as good as the previous one. So do you, now that you have a moment to think about it, let's try, this is 40 red on and 25 purple. Oh no, 40 red and 10 purple, and 40 purple and 10 red. Well, that the probability of purple is going to equal the probability of purple, given that it's on the left, times the probability left plus the probability of purple that's on the right times the probability it's on the right. Well, what's the probability that it's purple given it's on the left? Well, it's going to be 10 over 50 times 1/2, because you've got the probability of the intersection, purple and on the left, that's 10, divided by the number on the left, which is 50, plus the probability it's purple, which is 40 over the 50 times 1/2. And that is easier to calculate, but that's going to be, because I could say that's 10 over 50 plus 40 over 50 times 1/2, which equals, well, this is over 50, so that's going to be 50 over 50 times 1/2, which equals 1/2. So that is another application of this with again 1/2, so it's 0.5. Okay, we have now another possibility. Someone put up here, let's look at that one now. We have 1 purple on the left and 50 red and 49 purple over here. Okay, well, let's see that. That's the same thing. The probability that it's purple equals probability purple given that it's on the left times the probability on the left plus the probability of purple given that it's on the right times the probability on the right, which is going to equal, well, here the probability is purple given it's on the left is going to be 1 over 1 times 1/2, because you're only going to have one marble to pick, so it's going to be this one marble over the total number of 1 plus the probability of purple on the right, which is 49 over 50 plus 49 is 99, because you've almost got all of them there, times 1/2. And so this is going to equal, well, let's do it in WX maxima. Here, it's going to be 1/2 plus 49 over 99 times 1/2, which equals numerically 0.7, approximately 0.75, be 0.77. We can, let's see if there's a nice fraction. It may not be a nice fraction. Well, yeah, it isn't quite so much, but this is the same thing as 74 over 99. Well, so you can see this is very close to, it's one less than 75. This is one less than 100. So it's very close to 75, which is very close to 3/4. And that's greater than 2/3. And you can see that the whole idea here is that you've got one whole side that you only need one purple to make that conditional probability absolutely certain. And then the other one, you've got all the rest of the purples diluting the effect of the red ones over here. So there is a distribution where instead of 1/2, you have 3/4. So this is the best you can do for this problem. So this is sort of the solution that I was hoping that you guys would discover. Okay, well, that is the purple probability puzzle.